I'm Anil Kumar. Welcome to my series on linear functions. We'll discuss how to sketch graph. I'm Anil Kumar. Welcome to my series on linear functions. We'll discuss how to write equation of the given graph. I'm Anil Kumar. Welcome to my series on linear functions. In this video, we'll discuss how to write equation of a line when its graph is given to us. Equation of the line could be written in slope and intercept form, which is y equals to mx plus b. It could be written in standard form, ax plus by plus c equals to 0. We could also write the equation in point slope form, which is y minus y1 equals to m times x minus x1. The intercept form is x over a plus y over b equals to 1. We normally use this form to solve word problems related to lines. Now, these are special cases. So we have some special cases mentioned here, which will be these three conditions. Direct variation is the case when the y-intercept b is equal to 0, then the line goes through the origin. A horizontal line y equals to b is when the slope m is equal to 0, and the vertical line x equals to a is the case when m is undefined. Now, it's very important to note that if m is undefined, then you cannot write equation of line in slope-intercept form, right? Because m is undefined. So in that case, we get the line equation as x equals to a. The key parameters which you have seen here are slope, which is rise over run. If we have 2 points, x1, y1 and x2, y2, then the slope is y2 minus y1 over x2 minus x1. So we need to find 2 points on the line to get the slope. A, B, and C, the coefficients of x and y, and C, the constant, are all real numbers. Lowercase a and b, these are the x and y intercepts. So with that information, let's move on and see how to write equation of the given graph if the graph is of a line. So let's review these concepts once again, and then we'll begin with few examples. Now we have these three forms, which are very popular forms of writing equation. Most of the time, the equations will be written in slope-intercept form and in standard form. Let's take up a line, and then we will actually see how these forms are used to write down the equation of a line. So let us say that we have a line here which is kind of like this. Now in this line, when we say the y-intercept b, the point where the line crosses the y-axis is y-intercept b. X-intercept is the point where the line crosses the x-axis, right? So this is your x-axis, that is the y-axis, origin O. Slope for this line m will be equal to b, which is the rise, over the value of a here, a, right? That will be the slope of the line in this particular case. The distance here which we're talking about. Every line which is rising, so if the line is rising, we have a positive slope. Positive slope means that the value of m will be greater than 0. Let's take another line which is a falling line. Let's say like this, right? So let me call this line as L2. So in that case, slope of line L2, let me call M2, is less than 0, so it is decreasing. Is that clear to you? Right. So with that in mind, let's move on and find the equation of lines. So here is our first example. We are given two lines in this particular case. The question here is, question 1, write slope, y-intercept, x-intercept, and coordinates of 2 points on the line, and then find equation of the line from the graph. Any line which goes through the origin, if you have a line going through the origin, right, in that case, we also call this as direct variation. So the term here, which I have used, is direct variation. That clearly indicates that the line will pass through origin. So if that is the case, then the x and y intercept is right at the origin, right? So we can write down the values of x and y. Y-intercept, that is the value of b, for both the lines is 0. The x-intercept is also 0, right? So if you're thinking about a point, one of the points definitely is the origin. But if you need to find the slope, we need to identify some other point on the line. So let's take the red line as our first line. So I'll call this as a point on red line. And the coordinates of these points, this point is, the x value is 1, y is 2. So I can write 1, 2, right? So those are the coordinates of our line 1. Let me write down the points as 1, 2 here. Let's take the second line, and a good point to consider will be this point, right? So you have to look for a point which you can read fairly. -3 and the y value of 2. So this line has a point -3 and 2. How do we find slope of this line? Well, slope is easy. In the first case, we have to find what is the rise and then what is the run. Since origin is one of our points, right, 0, 0, rise is the y value. So slope m will be equal to change in y, which is you can say 2 minus 0, over run, which is 1 minus 0. So in this case, the slope is 2. In the second case, you can see that the rise is actually coming down by 2 units. So we can say that this is -2 and the run is 3 units, right? So if you go in this fashion, the run is 3 units. So it's a negative slope, -2 over 3. Now from here, we can definitely write down the equation of the line. Equation of the line will be of the form y equals to kx, simply because in this particular case, as you know, the y-intercept b is 0, right? So b is equal to 0. The y-intercept is 0. So if I substitute in y equals to mx plus b as 0, we get y equals to mx. So k is actually the slope. Perfect. Keeping that in mind, let me now write down equations for these two lines. So the line 1 is this line for us. For line 1, the slope is 2, and therefore we can write the equation as y equals to 2x. For line 2, the slope is -2 over 3, and we can write the equation as y equals to -2 over 3x. You can confirm that if the line is rising, slope has to be positive, and if the line is falling, the slope has to be negative. So I hope that makes sense, right? Now let's take up next example, which is also on direct variation. You need to write down the equation of these two lines. Let this be an exercise for you. I'd like you to pause the video, answer this question, and then look into my suggestions. Well, once again, both the lines are going through the origin, so it is definitely a case of direct variation. We'll consider a point on, let's say, line 1. Let me call this as line 1. Here we have a good point, which is 2, 2. So we'll write the point here as, we know this, both are going through origin, so that is origin, which is common to both. The point which we have considered here is 2, 2. So the slope m is equal to 2 over 2, which is 1, and equation of the line is y equals to x. Now let's do the second line, which is the blue one. A good point on this line is right there, whose coordinate point is minus 2, 1. Slope is the y value 1 over the x value of minus 2, and the equation will be minus half x. Is that clear to you? It is as simple as that. Perfect. Now let's move on and take more examples. This time we are considering horizontal line, right? So you see the line is horizontal. There are two lines here. One is red, one is the blue line. So we are considering the horizontal line. For a horizontal line, the equation is y equals to k, the y-intercept, right? It makes sense. If you have a line which is y equals to mx plus b, and if m equals to 0, in that case, as we said earlier, y equals to the y-intercept b. So in this particular line, you will notice that it does not have any x-intercept. The y-intercept in this case is 2.5. So the y-intercept is 2.5. X-intercept is none. A point on this, well, we can go with this 2.5 itself. Slope is 0 as we know, but anyway, let's take another point here. Let's say at 3, the y value is 2.5. It remains same. So the slope m is equal to 0 because the change in y value is 0. Basically, 2.5 minus 2.5 over 3 minus, that is 0, right? So which is equal to 0. And therefore, the equation of the line here is y equals to the k value of 2.5. It is a constant. Is that clear to you? So that is how you can find equation of a horizontal line. Now let's take the second line, which is right there. So we'll call this as line 2 now. A point y-intercept is a good point to take here, which is y-intercept with minus 3. So y-intercept, let me write this as 0 minus 3. The slope we know is 0, so m is equal to 0, and the equation of the line will be equal to the y-intercept itself, which is y equals to minus 3. Is that clear to you? So that is how, for a horizontal line, we'll get an equation of the form y equals to k, where k is the y-intercept. Let's take the next example, which is again a horizontal line. So this is a practice question for you. You can pause the video, answer this question, and then look into my suggestions. So whenever a horizontal line is given to us, it is important to find the y-intercept, and that gives you the equation. So for the line 1, since y-intercept here is at 3, the equation is y equals to 3. For the line 2, let's say this is line 2, the y-intercept here is, see, this is minus 2, that is minus 3, it is minus 3.5. So it is minus 3.5. So that becomes the equation of the other line. Now we have an example with vertical lines. So the vertical lines have undefined slope. As you can see, the run is 0, right? So the slope is rise over run. And in this case, run is equal to 0. So the slope is undefined. If that is the case, then the equation of line is always written in the form of x equals to a. So what we need to find is basically x-intercept, right? So we need to find x-intercept. So for the line 1, let's call this as our line 1. For the line 1, we do not have any y-intercept, right? So that is none for both the lines. For the first line, the x-intercept is minus 2. Since x-intercept is minus 2, I can write down the equation as x equals to minus 2. Let me just erase this. So we get this equation as x equals to minus 2. The second line here is with the x-intercept of 3. So I'll write x-intercept of 3 and the equation will be x equals to 3. So in case of vertical and horizontal line, it is kind of important to just check the intercepts and get the equation. So I hope this concept is absolutely clear. Now let's take the next example. Let it be a test question for you. So find the equation of these two lines. So we have the first line, which is, let's say, line 1. You have to find the x-intercept, which is minus 1. So for line 1, we have the equation as x equals to the x-intercept, which is minus 1. And for line 2, the x-intercept is 2, so it will be x equals to 2. Is that clear to you? So simple. Let's move on and take up the next example. So E is an example which I'll discuss in details, and Q is the question for you to work. The question here is, find the equation of line from the graph. We have to give equation in slope-intercept form y equals to mx plus b. So we should be in a position to find the y-intercept. In this case, y-intercept for first line is very clear. So I'll say line number 1, the y-intercept is at 2. So we can have this as a point. So I'll say point 1 is 0, 2. Now to find the slope, we need to find another point also. So this point here is absolutely clear, the x-intercept, and I'll take this as the second point, which is minus 2, 0. So that gives you the slope value, and the slope will be y2 minus y1, which is 2 minus 0, divided by x2 minus x1, which means x0 minus minus 2. So we get a slope of 1, right? So which is equal to 1. So we get m equals to 1. So since we have the y-intercept b as equal to 2, m equals to 1, we can write down the equation as y equals to mx plus b, right? The equation is y equals to mx plus b. In this case, m is 1, so it is 1 times x plus b, which is 2. So our answer will be y equals to x plus 2. Is that clear to you? So that is how you can actually find the equation of the line. Now let's look into the second case. We can read the y-intercept directly, which is at minus 1. So the y-intercept is at 0, minus 1. Another point on this line will be, so let's look for a point. This is a good point, right? So this point could be written as minus 2 and the x value, y value being 3. So we have a point which is minus 2, 3. So the slope will be change in y value, or 3 minus minus 1 over minus 2 minus 0, and that slope is 4 over minus 2, and that gives us minus 2 as the slope, right? Since minus 2 is the slope, y-intercept b is equal to minus 1. We have the equation y equals to minus x minus 2x. Slope is minus 2. So minus 2x minus 1. Is that clear to you? Perfect. So that is the slope. Right? Which is downwards minus 2x. Minus 2x minus 1. Clear? Let's move on and take the next example. Now, this is a question for you. I'd like you to pause the video, answer this question, and then look into my suggestions. You need to find the equation of line from the graph in slope-intercept form, right? So you need to write equation in slope-intercept form, which means y equals to mx plus b. So let's look into the lines one by one. Let's say this line here, we'll call this as line 1. The y-intercept is at 1. So I could write this point as 0, 1. We need another point which is minus 2, 0. So we can write the other point as minus 2, 0. Slope m will be change in y value. So 1 minus 0, which is 1, and 0 minus minus 2 is half. So slope is half. Since we know the y-intercept, we can write equation as y equals to the slope of half x and the y-intercept, which is 1. Is that clear to you? Right? This is the y-intercept b. Perfect. Let's find the equation of the second line now. The y-intercept for second line is at 2. So x value is 0 at y-intercept. Another point, good point, is 2, 0. 2, 0. Slope m in this case will be 2 minus 0, which is 2, and 0 minus 2, which is minus 2. So slope is minus 1. Let me write minus 1 here. And the equation will be y equals to minus x and the y-intercept, which is plus 2. Perfect. So that is how you find this particular equation. So I hope the concept is clear to you, right? Let's move on and take up the next example, where the question now is standard form, y equals to ax plus by plus c equals to 0. The question is, write equation of the line shown in the graph below in standard form. So you have to write the equation in standard form this time. Okay, process is same. You need to identify 2 points on a line. So let's say this is our line number 1, and on line 1, let's try to read the y-intercept, which seems to be at 1.5. And here we have a value which is minus 3, which is a good point. But I like to choose this point here, which is better to read 1 and 2. Does it make sense to you? 1 and 2 is a good point. And the other point here is minus 3, 0. So we'll consider these 2 points. So one point is 1 and 2. The other one for us is minus 3, 0. Slope m is 2 minus 0 over 1 minus minus 3. So we get a slope m as equal to 2 over 4. So that gives us the value of m as half. Now m is half for us. How do we find equation in this form? So we can use the equation y minus y1 equals to m times x minus x1. This is one way of going about. So we'll use this particular equation, which is point slope equation, right? This equation is called point slope equation. So y minus y1, we can use any one of our points, let's say 1 and 2. We'll use this point. y1 is 2. Y minus y1 equals to slope m, which is half, times x minus x value is 1. We can cross multiply, so we get 2 times y minus 2 equals to x minus 1, open the bracket, 2y minus 4 equals to x minus 1, and bring them together. When you bring them together, coefficient of x should always be positive. So we'll bring all these terms to the right side. So we get x minus 2y minus 1 plus 4 equals to 0. Or you could write this as, let me rewrite this right here, as x minus 2y minus 1 plus 4 is plus 3 equals to 0. So that becomes the equation of this particular line. Is that clear to you? Correct? So that is how we are going to find this equation. Now there's a lot of work involved in this, so I'd like you to pause the video, do it on yourself, and I'll do it on the right side. So let's take the second line where we have to identify some good points. This is a good point. So we are saying point A for us is minus 1, 0. Another point on this line could be, let's see. Okay, so another point on this line is, let's take this y-intercept itself, which is the x value being 0 and the y value being minus 1.5. So we'll take the other point B as 0 minus 1.5. Since we have these 2 points, let's find the slope. The slope will be m equals to slope will be m equals to y2 minus y1 over x2 minus x1. So in this case will be 0 minus becomes plus then over minus 1 minus 0, so which is negative 1.5. So we can write the equation in the form y minus y1 equals to m times x minus x1. Right? So we'll substitute the values, write down the equation and then solve. The y value which we'll consider is minus 1. So y minus 1 becomes plus 1 equals to slope of minus 1.5 times x minus x1, which is 0. So we have y plus 1 equals to minus 1.5. So it is better to write this in fractions, right? Since we will prefer to write a as a whole number rather than a decimal number, right? Okay, so multiply by 2. So we get 2y plus 2 equals to minus 3x, and bring the terms together. So we get 3x plus 2y plus 2 equals to 0. So that becomes the equation of this particular line. Is that clear to you? So this was kind of tricky. So when you want to write equation standard form, it is better to use the equation given to us in this particular form. Let's take another example in which we will use slope-intercept form and convert the equation. Perfect. So that is also alternate way of finding equation in standard form. Now in this case again, we have 2 different lines. It is a question for you to try. So I'd like you to pause the video, copy this question, answer, and then look into my suggestions. So we have to first identify 2 points on our line. So one of the point is here, which is 1.5, right? So 0, 1.5. The other point on this line could be at -1 we have minus 0.5. Let's take this point, which is common to both. At -1 it is minus 0.5. So these are difficult examples. I have purposely taken decimal values, right? So you could get in your test some equations which may involve decimal values. So we have 2 points on our line. One of them is 0, 1.5. The other one is -1 and minus 0.5. The slope will be difference of these two. So that means 1.5 minus, that becomes plus 0.5 over 0 minus becomes plus, and that slope is actually 2. Okay, so slope is 2. So this time we will actually write our equation in the form y equals to mx plus b, and then we'll convert. Okay, so that is what we're going. So that is the second strategy which we are trying to use in this particular case. So writing it in this form of y equals to mx plus b, we can say y is equal to m, the slope is 2, x plus b we don't know, so we'll find b using one of our points. Well, we know it is 0.5, we could have written directly. So okay, so we'll write this as y equals to 2x and the y-intercept is 1.5. In standard form, we have to write them all together on one side. So it becomes 2x minus y plus 1.5 equals to 0. Is that clear to you? So that becomes the solution for this particular equation. Now let's do the second one, which is right there. Now in the case of the second line, let's identify some points. The y-intercept is minus 1, I mean minus 1.5 is the y value. So I should write, let me change this. I should write 0 for the x value minus 1.5, correct? So that becomes y-intercept, and another point is we took common with this, right? So here we'll use the second point as same as we used here. So we have a point which is 0 minus 1.5, that is also the y-intercept, and we are using the same point minus 1 minus 0.5. The slope is difference of these two, which is minus 1.5 minus 0.5 divided by 0 minus 1, which is 1, and that gives you minus 1 over 1, which is negative 1. And so the equation is y equals to negative x, and the y-intercept is minus 1.5. Rearrange and write x plus y plus 1.5 equals to 0 as your equation, right? Is that clear to you? So that is how you get your equation. So that was actually a practice test question for you, and I hope you got it. We are at the end of this video. Now here is the last sheet, which is basically a worksheet. So you can actually pause the video at this stage. There are 6 different graphs, each have 2 lines. You need to write equations for these lines in different forms, whichever is best for you, right? So first one is the application of direct variation here. So this is right there going through the origin. It's an application of direct variation. The second one, we have 2 lines. One is horizontal, the other one is vertical, and then you can use slope and intercept form to write equation of these lines. You could use standard form to write equation of these 3 lines. That should provide you with good practice. I hope this video you find it very useful. Feel free to write your comments, share your views, and I hope this summary, which summarizes all the equations of lines, help you to understand what are the coming topics for us. So in this particular video, we discuss how to write equations, especially in two forms. One was slope and intercept form, and the other one was the standard form. We did use the equation which is point slope form to get to the standard form, but you could also obtain the standard form from the slope intercept equation. So that is your choice. In the coming examples, we'll take a few examples working with the intercept form of the equation. Now, direct variation, horizontal lines and vertical lines, those three cases, if you could recognize, within a second you can write the equation of a line. So that is very helpful. I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.